All right, number 9. This is just a connection problem. I wanted to know is it possible to find non-zero numbers x, y, and z, so that 13 to the x times 5 to the y is equal to 3 to the z. And we have a couple of reasonings. So no 3 is prime, so the whole number such as ax equals 3z for non-zero whole number x, and y do not exist. It says yes, the numbers are prime. The two sets of equations will be equal when x, y, and z become sufficiently large. It says yes, the sum of 13, 5 is 18, which shares a common factor with 3. So that's true. And then it says no, because 13, 5, and 3 share no common factors. There's no number of times 13 and 5 can be multiplied times each other to get a product which is divisible by 3. We could do some trial and error to see what's going on. So just play with some numbers. Let's just say we used the smallest that we possibly could with 13 and 5. So we used x and y to be 1. So we just did 13 times 5, which is going to give us 65. And then I'm doing 3 to some power. Just from this, whenever we raise 5 to a power, we're always going to end with 5, like 25, 125, so forth and so on. Raising 3 to different powers, we're not going to get something that ends in a 5. Okay, so I'm going to go ahead and say the answer is no, just by looking at this first example. So letting x and y be 1 to the first power, I'm getting 65. And just thinking ahead, anytime I raise x to another power or 5 to some power, we're going to get something that ends in a 5. I'm going to be multiplying 13 or some power of 13 that ends. I think we're going to end in a 5 every time. And this will not. So we want to say no. And I guess the reason being, I guess we'll go with D. They don't have any common factors, so no number of times can we multiply 13 and 5 and get a product which is divisible by 3.